Hi, I'm on section 2.1 again. And I think this is section 2.1. Yes, this is section 2.1, the last part of it. And I want to tell you about significant digits. These are also known as significant figures. They're very important. Let me show you why they are important. Take a look at these, these measurements. I'm going to make this bigger for you. Okay, what is the volume of water in here? Well, let's see. This is 20, there's a mark here, and this is 40. So this must be 20, 30, 40, 50. Okay, so it's almost 50 of water in here. I assume this is 50 milliliters. So, because milliliters is a very common unit for measuring the volume of water in chemistry. So it's almost 50 milliliters. Could I say that maybe it's 49 milliliters? Yeah, I could say it's maybe 49 milliliters. Here's what I cannot say. I cannot say it's 49.1 milliliters. Why? Because I don't even know that it's 49 milliliters. I mean, it might even be 48 milliliters. I can't tell because there are no little marks. This mark is 10 milliliters away from this mark. So there's a lot of milliliters in here and no marks in between these. So the best I could do is say, oh, you know what? It looks like about 49. The 9 in 49 is a total guess. It could totally be 48. So it's probably like 48.95623 but the best I could do is 49. That's the best. So what I just said there, 49, that is a measurement with two significant figures, two digits that I actually measured. So let me write that measurement down. 49, 49 milliliters. This one I was sure of, right? we all can tell that there is more than 40 but less than 50 milliliters are here. So we're sure of this. This is check mark, sure of that. This number right here, this one, not sure. This is the uncertain digit. The uncertain digit here. The last digit of any measurement that you make in chemistry class is the uncertain digit. Even if it was an electronic balance, a digital readout, the last digit on a digital readout is also the uncertain digit. Why? Because the machine guessed. It could have been, like if this were done by a machine, it could have been 48 milliliters. It could have been 49 milliliters. But the best guess is 49. That's the uncertain digit. Okay, notice this, folks. When you do the lab work with Dr. Valdez, I need you to write down the data in the proper way, meaning this is not 50 milliliters. If you measured this as part of your lab work, you do not write 50. You write 49. You must guess the last digit. Okay? All right. So let's look at this one now. Oh, wow. Looks like this is the same volume of water as we saw in here. Except look, there are more marks. I got 40. Oh, actually, this is not the same volume of water. This is more than 40, but less than 50. Isn't that what we had here? Yes, this is more than 40, but less than 50. Okay, this probably is the same volume of water. That must be why they drew these pictures next to each other in the book. Okay, so let's assume that this is the same volume of water. 40, 50. Now, this instrument, this is called a graduated cylinder because it's a cylinder and it has these marks in a gradual way. So it's a graduated cylinder. This graduated cylinder is a better tool for measuring volumes of liquids than this cup is. This cup we call a beaker. It's called a beaker because it's not just a cup. It's a measuring cup. But it's not just a measuring cup. It's a measuring cup with a little pour spout on it. And so we call it a beaker. So this graduated cylinder is better than the beaker because look, it has all these marks in between the 40 and the 50, whereas the beaker didn't have any marks between the 40 and the 50. What do these marks mean? Well, there are 10 steps here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 steps, and 50 minus 40 is 10 milliliters. So 10 milliliters divided by 10 steps, each mark must be 1 milliliter. Here, let me show you. I mean, that's easy for you to do in your head, but when the tools get more complicated, you might want to see this on paper. I subtracted the known numbers and I divided them by 10 steps. And that got me 1 milliliter per step. Notice that milliliters are on top, steps are always on the bottom. In the answer also, milliliters are on top, step is always on the bottom. So every step is 1 milliliter, 1 milliliter per step. That means I can just count 41, 42, 43, 44, 45, 46, 47. So this is 47 milliliters. So it's not 49 milliliters, it's 47 milliliters. Okay, I need to say something here about this tool. You do not write down 47 milliliters for this. No, because you must guess the last digit. Did I guess that this is 47? I mean, yeah, it's more than 40, so that was not a guess. Was the 7 a guess? No. I sat here and I counted it. 1, 2, 3, 4, 5, 6, 7. So that is not a guess. So what's the guess? Looks like the top, it looks like this water level is sitting squarely on the 7 mark. That means the next digit is 0.0. This is 47.0. So this here, this is 47.0 milliliters. Ladies and gents, that is a much different statement than 49 milliliters. Not just because they're 2 milliliters away, but because this has a decimal place here. The number of decimal places available in your measurement, we call this the precision. There are 2 meanings for the word precision, but this is the most important one. The number of decimal places your measurement has, that's the precision. Your book defines the word precision with the other definition, which is less important. This is the most important one. Okay, so precision. This is a more precise measurement. Why? Because I am sure of this number, I am sure of this number, but this number was my guess. You know what that means, right? It means this is not, oh, about 47 milliliters, it might be 48, it might be 49. No! This is 47 milliliters. It might be 47.1, but it is 47. These two we are sure of. This is the uncertain digit. Uncertain. Do you see the difference? You see how that's different? Okay. So you always need to guess the last digit. I need to make one more comment about this graduated cylinder here. Notice that I didn't try to read the volume from the top of this water level. Notice the water level is a little smile. The smile is called the meniscus, and you must always measure the water level at the bottom of the smile, the bottom of the meniscus. Okay, and that's important. So the reason why that's important is because in a future quiz, I'm going to give you pictures like this, where you're going to have to measure water levels, and you can't be measuring it right there. No, that's the wrong answer. You need to measure it right there. That is the correct answer, all right? So this smile here, that is called the meniscus. Meniscus. It's a C there. Meniscus, okay? Important word, meniscus. That's the surface of the water, the curved surface. There are some liquids, such as mercury, which have a meniscus that curves in the opposite direction. In those cases, you must measure the liquid at the top of the meniscus. All right? In other words, you have to measure the meniscus at the end of the curve, the center and the end of the curve. Okay? And with water, it's the bottom of the meniscus. With mercury and some other rare liquids, I guess. I don't know any others than mercury, other than mercury actually, personally. But you know, who knows? Dr. Valdez. Dr. Valdez would totally know some other liquids besides mercury that have an upward curving meniscus. But that's all for now, but we are not done with significant figures. This is only the first video.